So how does the longest full moon proves that the globe system or globe model is correct and there's no such thing as the flat earth? First of all, I heard about this 11 hours or 10 hours or maybe more full moon, a 100% full moon, and I was shown this on mooncalc.org. So I started to study the issue, and I noticed something that these sites will not show you the phase like this. Only show 99.9 or 100. So if the moon phase actually is 99.96, this will be rounded to 100. So now this is a possibility. So when we say the moon phase is 90%, this means that we're seeing a portion of the moon, not all of the moon. And this missing portion here, the more it increases, the more or the less we see a full moon. So how to calculate this? First of all, I draw this moon, and this is the sun direction. This is the lit half, and this is the dark half, and this is the direction to the Earth. Now, I think it's obvious here that this is the part that we see, this width here, and this is the part that we don't see. So the first thing I did is I draw this line from this point here, perpendicular until here, and then another line here. Now you can see there's a third line here, and that is a triangle that I know this angle, and of course this is 90. This angle is equal to the deviation angle here. This deviation angle is the angle between the Earth, Moon, and Sun. So if I know this length from this point to this point, and I remove for it or subtract from it the diameter of the moon, I get the length of these two extensions, and they are equal. And I call them extension 1 or x1. So here's the little bit of math. This is the x1, and this here, x2, is the portion that I'm not going to see of the moon. I won't go into the math. You can just confirm it on your own. So what is the factors that change this deviation angle? Of course, the first thing is the moon phase. The moon position after being in a full moon. And that's mainly depending on the movement of the moon in its orbit. But that's not everything. So here I have like two snapshots of the Earth and Moon. And as you see, this is here, the deviation angle. Now let's say after one day, the moon will be in this direction in relation to the Earth. And so the line from the moon to the sun will be this one. And this will be the deviation angle. Switch it to the other side. This means that we already passed the full moon. But the reality is the whole Earth and Moon system is moving clockwise around the sun. And so it's not yet full moon. So this angle increase by around 13 degrees per day. That's the moon speed, the moon angular speed. And this angle, I don't know, this line, or the line of the baseline separating the light from the dark, moves by 1 degree in the opposite direction every day. That's the 365 days Earth rotation in its orbit. So we have a factor that increase the deviation angle and a factor that decrease it, and we can calculate that. So I put these equations here on Excel sheet for the moon and the earth. The orbit takes the orbit 360 degrees, the period is 27 and this 365, and so the degrees per day is this and this. And then here I put how many hours after the full moon, or starting from the full moon. And then if I say, let's say 1 hour, the moon and the moon and earth change in angle is this value, and then I subtract this value from this and I get this 0.51. This is the deviation angle, this is the horizontal extension, the diameter plus the x1s, and this is the x1, one of x1s, and this is the, I call it the dot extension, is the x2. Let's go to the drawing just to remember what I'm talking about. The x1 and the x2. Right, so now let's put 2 hours. At 2 hours, the precise moon phase is reducing to 99.992, and that will be rounded to 100 after 3 hours. As you see here, after 4 hours, you see it's now 99.96, but it will show as 100. After 5 hours, still 100. After 5.1, now it showed 99.9. So we'll stick to the 5 hours. So 5 hours after the full moon, the 100th full moon, sorry, in this precise, we'll still have a reading on mooncalc.org of 100% full moon. So that's 5 hours before and 5 hours after. So that's a total of 10 hours of full moon, or indicated full moon to be accurate. Now I was playing with this application that I made, and I had some idea, and it's 177 hours, 0.17. Right, so the deviation angle is 90, and by logic that would mean that will be half of the moon is visible to us, or half of the moon is light. And in days, that is 7.38. Now what's this number? Let's see the equation. If 7 multiplied by 4, because this is 90 degree, if we multiply by 4, that's 360 degrees. That's the whole rotation, right? So rotation of phases, not rotation of the moon, right? So after 7.38 days, we get 50% of the moon. Multiply that by 4, you get the lunar month. And here it is. From new moon to new moon, 29.5. 29.5. What else do I need to say? Thank you.